Hi, everybody. Welcome to Automating Offensive Security Infrastructure. During today's talk, we're going to be discussing how we can use Terraform and Ansible to build cloud resources, specifically AWS resources, for the purposes of today. My name is Joe Barry. I'm a senior consultant here on the attack and pen team at Optiv. I've been here about 4.5 years, 5 years this November. Been in security consulting as of today, over 6 years. Performed penetration testing assessments and the like. Before that, I was a system engineer for a very long time. Started out as a help desk guy over a decade ago. As far as automation goes, started playing with it about 4 years ago, very lightly. Pretty heavy about 2 years ago. So getting into the talk itself, why should we automate? So in order to understand why we should automate, we have to understand what are we performing. And as you can tell from the title of the talk, we're looking at offensive security or security assessments. So those that perform security assessments understand that they're unique on one hand, but also very repetitive on the other hand. So they're unique in the fact that you're looking at different environments, sometimes on a weekly basis, sometimes on a monthly basis, and they're different configuration, different technologies, different ways that they're all tied together. But they're repetitive in the fact that they're similar technologies. We're still attacking networks, still attacking cloud environments, we're still attacking web applications. And though they may be uniquely configured, they're still the same types of environments. You got a Windows shop, a Linux shop. So you're going to be looking at using the same type of infrastructure and the same types of tools over and over to perform these assessments. Now, when we're performing these assessments, they're always time boxed. Always, either a week at a time, month at a time, 6 weeks at a time. It just depends, but you have that that time frame set to set up all your stuff, get it ready to go, perform the assessment, compile all your data, compile your findings, put it into a deliverable or whatever form it needs to be digested and sent to those stakeholders that need to do something with it. Along with that is the handling of all that data, right? So, especially in consulting, you have different client data that you don't want merged with each other, and you want to keep it only for the amount of time that you need to complete your work, and then you just need to get rid of it. And that's the data retention portion. So, how can automation help you avoid issues with all that? Well, probably the biggest thing is time delays. We've all been on on assessments, where you're trying to get things set up. Maybe you're a little behind, right? And the tool isn't working for some reason. I can't get in packet to work. What's going on? All the dependencies aren't installed because somebody else installed something else on this box. So you don't want to try to use that shared infrastructure. You want to use individual infrastructure, set up the right way, and automated. So that way you're not doing it manually over and over and over every week. So you save time. And along with automating things and automating tasks is that it's going to be executed the same way every time in the same sequence of events, so that way you'll avoid configuration mistakes. That can be twofold. One, setting up tools properly so they don't break and you don't waste time troubleshooting. But on the other hand, also you can get rid of indicators of compromise or IOCs. So you can, if you're setting up things, maybe you might forget to take out a header, or you might accidentally leave a default certificate. Things that get you burned on assessment, especially if you're trying to be evasive, like on a red team or whatever, you're trying to use non-attributable infrastructure and you get burned because you leave some things in place. Last but not least is mishandling of data. Our automation orchestration can help you stand up separate environments for these different assessments. That way they keep all the data segregated. You can keep it all within that one environment that you stood up, retain it for however long you need it to complete that time box assessment, and then destroy it whenever you're done. So what can we use to automate? All sorts of things. There's lots of tools. You got Chef, you have Puppet, Terraform, Ansible. Those are the two that we're going to be talking about today. Terraform is really awesome at building and destroying resources. It's my favorite for that because what Terraform will do is uses configuration files to connect to a provider and build resources to a specific way. And it uses these lock files or state files because it is a stateful tool to build a resource. It maintains its baseline, and then you can destroy it at will based on those files that were created. Terraform maintains the integrity of that environment based on what you tell it to do. So how does it do that? It uses HCL, which is HashiCorp language, and it parses whatever code you have in your Terraform files, and it translates it into an API call and sends it to that provider. And that provider plugin, underneath it, it's kind of a hierarchy. Underneath it has a different resource types and data source types that you can configure that way to build the required infrastructure you want in those API calls. Really, really awesome. Probably the easiest one to actually stand up something, maintain it, and then destroy it easily at the end. Ansible can also build things. You could totally do that with Ansible, but it's not stateful. It doesn't manage that baseline, and it's not as easy to destroy at the end. Where Ansible really glows and shines is it's using their orchestration playbooks. Um, it uses a really easy YAML markup language with all these different models, and these models are separate sets of code that are pre-built that will execute commands on, like, say, a remote node or remote host that you just stood up to configure that. And you can get really, really detailed in the task within your play or playbook to stand up something, to stand up some technologies or configurations. It is stateless, but it is idempotent or idempotent, however you want to say it. Excuse me. And what that means is when you execute a playbook, you have a series of tasks. It will connect to that host over SSH, and it will attempt to check and make sure those tasks haven't been executed first. And if they have, it'll skip that task. Um, so that way you don't overwrite things that may have already been there. So how do you set these guys up? Terraform's based on Go. You can actually download the binary for whichever platform that you're using it with and add it to your path and execute it, and you're good to go. You could also compile it from source, or you can use a package manager, like Aptium or Chocolatey for Windows. Though the easiest way is probably just to download the binary and add it to path. Ansible itself is based on Python. So being a Python tool, you can install it with pip. If you're on a Mac, you can install it with Homebrew. Linux, of course, pip, or a package manager, you can install it like apt. It's really requires a Unix type system. You can use it on Windows. Some common things that you can use it on Windows with are, say, like a Linux virtual machine, localhost, local virtual machine, or you can set up Windows subsystem for Linux and run it there. So I do want to say, as we go through this, I do have a resource down here. There's a URL. It's github.com/optiv/pyautoaws, and that's a code wrapper I wrote just for this talk. Very, very basic, very simple. We're going to get into it at the end of the talk. But inside those directories, which are titled API GW, API Gateway, and EC2, there are some Terraform configuration files and Ansible playbook in the EC2 directory that you can use to follow along. They're a little bit different because I'm going to show you some really basic examples first before using the code wrapper. But if you want to look at this code, and I'm going too fast in the slides, you can reference it, and you can use it to follow along or check things if you need to follow up on something. So we're going to do two things. We're going to set up an API gateway with Terraform, and we're also going to set up some EC2 with Terraform and then configure that EC2 with Ansible. So starting out with the API gateway, what is that? So API gateway service manages APIs. You can stand one up, you can monitor it, you can secure it, and you can pick different types of APIs. In our case, we're going to set up a REST API as an HTTP proxy for the purpose of password guessing. Password guessing is commonly used by offensive security guys because it can hide where you're performing that password guessing from, so that way you can be more evasive. Lots of folks will stand up, cloud instances and rotate the request through those. So you might stand up 20 or you might stand up 50 cloud instances. But you can do the same thing with an API gateway. It can be used as a proxy. And an API gateway, from what I've seen, I've stood up web servers in the past and sent requests to them and kind of monitored the source IPs that it was coming from. And usually it's from a /23 size source subnet. So that's pretty awesome, right? So you might stand up 50, cloud instances and rotate through those, but an API gateway, you might get as much as, close to 500 IPs before you start seeing a lot of repeats coming through. So that's pretty advantageous. So there is a note here. Review the AWS acceptable use policy and any simulated event submission requirements. So AWS does allow you to use their infrastructure for penetration testing, but before you do any of this work, make sure that you review the acceptable use policy, make sure it's within scope of what they deem correct, and if you need to submit an event saying that, hey, I'm going to be performing penetration testing with this infrastructure, blah, 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 for this period of time, make sure you do that. So you're within the rules. So how do we do it? How do we get into Terraform? How do we build an API gateway? So the main configuration file for Terraform is the main.tf file. And there's a couple other files that we'll go over, but that's the main one where you actually configure the provider and the infrastructure objects, the resource objects. So in those resource blocks, you define one or more objects, right? So you can see here at the top of the resources, we have provider AWS. So in that provider block, we're going to configure how we connect to the provider. And then below that, these are the minimum different resource objects we need to create an API gateway. There's quite a few there, but that's not even all of them. That's just the minimum amount we need to set up this API so we can perform an API, perform password guessing through that API. So let's give it a look. So this is what it looks like actually within a directory. You can see we have a Terraform directory with an API gateway. Now remember, these things are stateful. So Terraform is going to look at these Terraform configuration files, main outputs and variables, and it's going to set up and initialize and create a lock or state file for the execution of this infrastructure. So what's that main file look like? So you can see here, we have the AWS provider configured, and I know I see there's keys there. Don't worry, they're burner keys, burner account. I just wanted you guys to see what they would look like without any, redaction or whatever. But you see the AWS access key, AWS secret key, and the region that we want to connect to for the provider built into that block. So when you're assigning values to these different options, you can assign it either a variable or you can assign it, a constant. So we're going to go over those here. So as we walk through this gateway setup, we're going to say, hey, we want to set up an API REST API, which we discussed earlier, and we're going to call that resource block API gateway, and we want the name, which is going to be the name of the gateway in the console. If you go into the console and look at it, that's the metadata name that you're going to give it. It's going to be a variable, and it's going to be a regional type API gateway, so tied into the US East 1 region. So going through, it's going to start building the different resources and objects that it needs to build on each other because they're all codependent on each other, right? So what method are we going to use? We're going to use any HTTP method, so it'll support put, post, etc. What is the method response we're going to get? So when you submit a request, and what kind of response are you going to get back so you know that it was valid? It's going to be 200 status code, right? And then we're going to get down further into it. What about the API integration? So yeah, we're putting requests to the API, but what is it connected to on the opposite end? What is it integrating with? So we're setting up a HTTP proxy, and we're going to attack whatever URI you want to put in here. So it could be a login form, like we mentioned before. It could be a Microsoft 365 API, Graph API, the RST API. What do you want to put in there? You put in your URL. Integration response, what type of response are we going to be getting? We're going to be getting application JSON type. And then the API stage is the last portion of the invoke URL when you want to use the API gateway. And you have to give it a name. The default, if you go through the console, is just a /, but when you're building through Terraform, you need to give it a stage name. And we're password guessing, so we're just going to use login. And then at the very end here, this last resource block is actually deploying the API. The rest are all just setting it. The first one is connecting to it, the provider, then all setting up the API, and then this last one is actually launching it. So the other two files that support the build of this infrastructure is one, the variables file. So if you're going to use variables in that config main.tf, you have to have a variable file defined. And one of them was called name, and the other one was API URI, and you can put in the description. so you understand and remember what those were for. The other file is the outputs.terraform file, right? At the very end of the Terraform run, which you'll see, there'll be an output section, and you can tell Terraform to output a value. And in our case, we want to be able to do our password guessing right away. So we put in a value, a description of a deployment invoke URL, and it's going to display that URL that it outputs during the build. So what's that all look like? First, when you're executing it, you have to initialize it. So we did discuss Terraform and how it's stateful. So within that directory where you have those configuration files, you're going to initialize it, and Terraform is going to install those plugins that are required for AWS because it's a provider AWS. And it's going to create that lock file that once you build the infrastructure, it'll take a snapshot of what that infrastructure looks like and hold it in that lock file. So once it's completed, it'll go in and say, oh, okay, cool. Terraform's been successfully initialized. And you can now use Terraform plan to see if there's any changes needed, or you can just directly go in and use Terraform apply to set things up. And that's what we're going to do. Once we have Terraform init completed, we'll go here. You can see Terraform apply. You can use auto approve. Otherwise, it'll say, hey, is this the configuration you want? Does it look good? We'll put auto approve there to skip that step. And then you can see here, this is how we add our variables. Dash bar name equals my API, and the API URI variable, we're going to use the RST endpoint that we use in our Optiv Go365 password guessing tool. So once you execute it, it'll say, okay, cool, we're going to create these resources, and it starts going through those objects, those resource objects. You can see here we're creating them, starts assigning, once they're built, it starts assigning those AWS IDs. And it gets all the way down till it's done. It says, all right, apply complete. We added 7 different objects. And then we get into that outputs.tf file, that output section. We have a deployment invoke URL, and boom, you can snag this URL and start using it. You can see that unique identifier in the front with that common name for the API for US East 1 here for that domain, and then your stage name at the end. So how can we use that? You can use with all sorts of stuff as long as the tool supports it. Here we're using Go365 with the RST endpoint because we fed it that RST URI. Obviously, use the tool, give it a username, password, domain name, and then feed it the URL for the API gateway, and the tool itself will automatically snag that gateway and use it as an HTTP proxy. Other tools can support this as well. Go365 is not the only one. I use it with Burp Sweep all the time, especially if I'm not using using it with Microsoft 365. You can use a login portal with a post request and intruder and change the target from the target host address to the API gateway. This is going to be what way more detailed and way more commonly used, which is the Elastic Compute Cloud EC2. Because we're going to need infrastructure for all sorts of things. EC2 is the compute capacity in AWS cloud. It's where all the virtual computing is built up, all those virtual servers. So how do we use that? We use it to build phishing infrastructure, command and control infrastructure. You can use it for open source intelligence tools. Anything that you need that needs to be built in the cloud and or non-attributable for AWS, something that you can build up and tear down and have multiple things with redirectors, etc. You can do that in the cloud. So how do we build EC2 with Terraform? Same setup. We're doing the same thing. Main.tf file. We're going to describe one or more infrastructure objects. And you'll see here there's way less objects, and that's because EC2 requires less objects to build, but within those resources, there's going to be a lot more configuration options that you can do. So let's see what it looks like. Go to my Terraform folder for EC2, and you can see here, same setup, 3 files, but they're going to look different, right? Same provider, but now we're changing the type of resource that we're sending to that with that API call. So whenever you build an EC2, you do have to assign it to a security group. Now you can assign it to either an existing security group and just feed resources, the EC2 resource, the security group ID. And you can pull that with a data resource, which we'll get into here in a second, or you can build a new one, right, which is managed by Terraform. And that's what we're going to do here, build a real basic one. So you can see resource AWS security group, and we'll title that group resource group EC2 access. And then we're going to, in the AWS itself, in that US region 1, we're going to build an EC2 access named security group with outbound rules of everything's allowed out, and inbound rules, real basic, just port 22 for SSH. And the way we can lock it down is by feeding in a variable IP. So if you want to feed in the public IP of your home, if you're a remote worker, you can feed it that, so that way you can access it directly from your home, or you can feed it a range from your workplace, like a /24. Whatever. You can get down in the nitty gritty. You can allow web ports from all. So say you're going to stand up EC2 infrastructure for, command and control, and you want to be able to have listeners coming back. You can stand that up and allow those listening ports from anywhere, but also lock down your admin panels. Like for Cobalt Strike, it's TCP 550, or some of the other, for Go Fish, I think it's through at 3333. You can lock those ports down that you don't want open to the public. So that's what we're doing here. We're standing up this EC2 block, and this data block here is going to be used during the creation of the EC2 instance. And what we're creating is what we're pulling and creating for use is the most recent Ubuntu version. So you have an owner here, Canonical. That's Canonical's ID. So if you're used to going into the EC2 console and standing up a VM, you have to select your operating system first. So you want to use this code for Canonical, and it's going to filter on the most recent Ubuntu version based on virtualization type. These are the two filters you need to filter on that Ubuntu version. And it's going to be used here in our AWS EC2 instance for AMI. And you can see data, AWS MEMI, Ubuntu.id. It's going to pull that ID that it filtered on and feed it into the build. Count, you can build 1, you can build 4, you can build 18, doesn't matter. You can build as many as you want. In our case, we're just going to build 1. And it's going to be the free tier T2 micro. We want it to have a public IP address. And whenever you build an EC2 instance, you have to have a key pair created within that region that you can use and assign. So that way you can access your EC2. So we already defined that previously. We're not going to go into it here, but we have an AWS underscore SZC23 key that we're going to use. And then the security group that we're going to assign it to, we're going to pull it from that resource that we built, AWS security group EC2 access.id, pull that ID from that resource that was built and assign the EC2 to it. We want our root volume to be 16 gigabytes, and we're going to assign a variable name for the name of the instance for the name metadata within AWS. So we also have those two files. You can see here we still have that name variable, name tag assigned to the resource, but we changed it from the URI to the IP, and that's going to be the public IP that we need to put in for access. Outputs, instead of having a deployment URL to use the API gateway, we actually want the public IP of that instance, so that way we can SSH to it. So what's that look like? Again, Terraform apply. We're going to auto approve it, so we can just skip that prompt. And we're assigning the variables. We're going to call it my EC2. And just so we can show you what it looks like, put in the Google DNS IP, and that security group will build a security group allowing SSH port 22 from that IP. So it goes through the build process. You can see here it builds a security group, that's security group ID, and then it builds the instance, that's the instance ID, and then boom, at the end, we added those two resources, and bam, You're right there. You have your EC2 IP that you can SSH to. Now it says it completed in 20 seconds. It built in 20 seconds, but since we haven't built in a wait to this Terraform the um, configuration file because we're not configuring anything yet, it might still be initializing. So it might not be quite ready for SSH access yet. You might need to wait another 30 seconds, but the build itself is done. Terraform submitted it. AWS is doing all its work. So how do we destroy these things with Terraform? Because we were just talking about that earlier, right? And that's one of the things I love about how it's stateful and you can just tear things down super easy. And it's true. It is super easy. All you have to do is change from apply to destroy, and it'll tear all of that down, allowing you to destroy stuff in like 30 seconds. So if you think about it, you can take these configuration files, like say you have a new engagement and you set up a project folder for it, and you want to build some cloud infrastructure for it. Create a directory, copy those configuration files into it, do Terraform init, Terraform apply, maintain that infrastructure for as long as you need it, and then you can tear it down with Terraform destroy. Now you can put in Terraform destroy, but it will prompt you if you have a variables.tf file, and you submit Terraform destroy without the variables, not using the same command, it'll just prompt you to put in some information for those variables. You don't have to put in the same information. You can just put in like YY or XX, whatever, and it'll still destroy, but it's just easier just to submit the same request again. So now we're getting into Ansible, my favorite. So Ansible is really cool because you can get super detailed, like I was saying, building this stuff up. It's a blueprint, like we were talking. It's a playbook or a play, and in that play, it'll has a series of automation tasks. It's repeatable. You can run it over and over, and it'll orchestrate the installation of whatever you want in the order that you want based on how you set it up. So for our purposes today, we're just going to do something really basic and install some tools and packages. First, add a repo for a specific tool we want to add, update the cache, install some other packages, and then install Go version 119. So let's look at that. Clear this out here. So you can see here we have the playbook. All right, so here's our EC2 playbook. Pretty common to see a comment at the top describing what the playbook is or how you want to use it. It'll always start with these 3 hyphens. And the name of the playbook of the play will be here, playbook to install all packages. You define what host you want to run this against, which will be all that you feed to the command. And you can set up variables within the playbook. Here we have an Ansible user. We want to call it Ubuntu because we're building with Terraform Ubuntu host, and we want to install a Go version 119. And you put these things here so that way if you want to build something else with Terraform or you want to install a different version, you can easily change it here at the top of the playbook instead of having to look through all the code to figure out where you need to change it. So once you have all that set up stuff in the beginning, you jump into your task. And again, this is that easy markup language that you can use. You have to give a name for the task. In this case, it's going to be installing tool packages. And as we know, to install from apt, you have to have privileges. So to become sudo, become something with privileges, you're going to say yes. That's what we want to do. So if you have a lot of tasks that are related to each other, you can set up a block. And in this block, you'll have the same privileges, and you have a series of steps that you want to execute in order. And we want to install a specific version of PHP that may not be in the apt repo right on Ubuntu. So we're going to add the PHP 8.1 repo, and we're going to use this module block, which is a block of code pre-built by Ansible that executes these tasks. So that way, all you have to do is name the module, and hey, I want this repo added in a state of we want it to be present, so we want it added. So you just add in the repo, and it'll go out. And it'll go into the correct sources.list file and it'll add it for you. It does all the work for you. Super easy, right? So very powerful. So it keeps your code really short and simple because you can execute system calls, system or shell commands with Ansible, but it's way, way better and recommended to use the actual modules that are provided by Ansible. So you can see here we're adding the repo, and then we're using the apt module to update the cache. Yes, we want to update it. And then we're going to use apt repo again, which you can see here, Ansible built-in apt and apt, and I put that in because you can leave off this beginning part here. You don't have to put Ansible built-in. You can just use the last portion of the module name, which is apt. So these are actually the same packages, but we wanted to update first before we actually did the installs. And here we're installing all these tools, essential packages, certbot, that PHP package that we needed from that additional repo, Nginx, unzip, and map. We want those all to be present and installed. Next, we want to install Golang. And again, we want privileges to install it because we want to put it in user local path. So we want to become yes. And you can actually, the default's sudo, but there's different become methods that you can use, like dz-do, and there's quite a few different become methods that you can use that you can configure. So I just put that here so you can see it. But again, we're going to set up a block because these were all related. And first, we're going to use the get URL module to download the tar file for this Go version that we configured at the top from the repo, right? And we're going to download it to our home directory, which will be /home/Ubuntu. And that file, we can then add permissions to it. So it'll be 0440. Once it's downloaded, it'll go to the next task. It'll extract the Go tarball. So we're going to extract it from this source, which is our home directory. And then we give it the name of it, which is that new Go version. We basically use the same string. And we want to unarchive it to user local. And we don't want to copy it. We just want to uncarve it to that destination. So if you're familiar with Go, you want to have Go directories for your different projects and whatnot. So here we're going to use the file module to create different paths. So you can do for loops in Ansible. And this is a small example. You just put an item here, and then it'll loop through these with items. And you can see here we want to set up home Ubuntu Go, home Ubuntu Go bin in our home directory. And who owns that directory? You can see the state. It won't be a file. It'll be a directory. It'll be owned by Ubuntu and the group Ubuntu. So once that's all complete, it's downloading the tar file. It's extracting the Go. It's extracting it. It's creating the Go directories. And then we want to be able to SSH to this host and just use Go right away, not have to worry about setting Go environment variables or setting the path so that we can execute Go. So using block and file module, we can say, hey, we want to modify the bash RC file. We want to put this code block in there with a little marker saying that Ansible put it there. And we're going to insert it at the end of the file. And if that bash RC file isn't created, Ansible will create it for you. So what does that look like? So first, obviously, we need Terraform to set up the host, the Ubuntu host. And we get a host with an IP 386.200.0. And then we execute the Ansible playbook. That's the playbook command that to execute the EC2-playbook.yaml file. -I is the option that you use to feed it either a host file without a comma or an IP with a comma. So if you submit that command with a comma, without a comma, it'll say, hey, this file titled 386.200.0 doesn't exist. So if you're using IP, make sure to put a comma at the end. If you're giving it a host file with multiple hosts, like say you built 3 EC2 instances and want to run this playbook against all 3, you feed it that host file. And since we talked about before, Ansible uses SSH to connect to the host and execute the commands, you need to feed it a key file. In our case, we have AWS source 0con23.pem file that we have in our SSH directory that we're going to use to connect. So then that play starts. You can see here playbook to install packages. It's going to gather facts. So what is gather facts? So Ansible is just collecting information from the remote host about the system configuration and health of the host. It stores it in JSON, so that way, if it needs it in the future, you can use it for different tasks. But something that you'll see, and you can set that in Ansible configuration. Then it starts going through the tasks. You can see here it's adding the PHP 8.1 repo. It's creating, and then it goes all the way through that, installs all the, I didn't display everything here, but installs all those tools. It's now going into the Go install. It's creating those Go directories, modify the bash rc file, and you can see here everything was okay. We changed 7 things, which means 7 things were actually performed and 0 failures. Boom, good to go. That whole setup probably took less than a minute, 30 seconds, less than a minute. So what did it look like? When you're done, you can SSH to the host, and this is the result you get. You can see Go's installed, PHP, certbot's installed, mmap's installed, everything's there ready to go. So you can see how that's pretty powerful, especially if you're doing this on a weekly basis and you have a bunch of weekly assessments. Man, it's so nice to be able to just execute these, use Terraform, use Ansible, stand all this stuff up quickly and in the right way every time. So how can we automate the entire process? And earlier we discussed using a code wrapper. And I wrote a very, very simple one. It's meant to be simple. And it's called pyautoaws, written in Python, obviously. And what it's doing is it's automating the type of build that you want. And in our case here, it's either an EC2 instance or an API gateway. And it's automating the order of operations. So if you're selecting API gateway, obviously it's going to just execute those Terraform files. But if you're executing the EC2, you want to build the Terraform instance and then execute the AWS, the Ansible code against the AWS instance. And also it's automating variable assignments. So that way you can just take this tool, like we said before, copy it, either build and destroy on a weekly basis with this, or you can copy it into your different directories for your projects and automate the variable assignments. That way you can use the same configuration files. You don't have to go into the playbook, into the Terraform file and change everything, change the names. You can just feed all that information into the tool, like the URI endpoint and the tag names, and it'll automate all that for you. So one thing I will note is when using this tool and automating things in sequential order, especially between Terraform and Ansible, you run into some flow issues. So you want to set up an SSH agent. And flow issues, I mean, is when you stand up an EC2 instance with Terraform and execute Ansible with a code wrapper, Ansible needs to Terraform to finish initializing and setting up that EC2 before Ansible tries to connect, or else it's going to fail and everything will fail. So you build that into the tool. So you need to set up an SSH agent. And you can do that pretty easy. And I'll show you real quick if I could type. So you can see here right now I have no SSH agent identities. And if I want to add one, I just add my key file that I have created for that region. I'll add it. You can see the identity's added. And now you can see it there. And now we'll have Terraform configured. As you can see, if you look at the tool and the configuration files, you'll see in there that's going to use an SSH agent. So with all that set up, you execute the tool. What is it going to look like with an API gateway? This obviously isn't going to use an SSH agent, but what's going to happen is, excuse me, is that it's going to change the directory, because you can see in the pyautoaws tool, there's an API gateway directory and an EC2 directory. So it'll automatically change your directory into API GW, initialize Terraform, as you can see here, install the necessary provider modules and dependencies, and set up the lock files, and then it'll go through and actually set up and configure the API gateway based on the variables you fed it with the tool, which in our case was the same login URI and same name, and it spit out the API gateway, and all you had to do is use the tool itself. So that's nice. So from the same, using the same tool from the same directory, if so say on a client, you have to set up an API gateway, you need to set up the EC2, you need to set up CloudFront, etc. You can use a tool like this in the same directory, same project directory. So if we execute EC2, you can see here we're feeding it the ID, secure ID, the key name, the region that we want to build it in. We're using an EC2 instance. We're only building one EC2. You can feed it, tell it to build 4, and we want to name it source 0 with our source IP of 8.8.8. You know, whatever IP you want to give it. It's going to change into that EC2 directory. It's going to start building. It's going to provision based on the variables. You can see here, there's that AMI ID that it gets from that data source. It's going to build T2 micro. We fed it AWS SCC23 as a key name. So it's going to pull all that, build it with Terraform. It's going to build a security group. You can see here we fed it 8.8.8.8. So it's going to lock down that SSH service to that IP. And it's going to name that security group EC2 access. And then this is where it's going to get into waiting for Terraform to finish executing. And this is where we need the SSH agent. So it builds a security group, builds the instance, and now before Ansible runs, which is going to run as a command within Terraform, we need that instance to be ready to go, and we can use Cloud in it. So within that resource, you can set up a remote exec using Cloud in it to connect to that remote host via SSH using the SSH agent. And once it's connected, it'll check the health of that instance itself, make sure it's ready to go. And once it says, okay, cool, it's done, Cloud init is complete, the next portion of the Terraform script will run, which is actually executing a local command of Ansible with these options. So it's executing Ansible playbook against, you can see now it's executing against a file, not an IP. Because what if we built 3 EC2 instances with pyautoaws? We want to execute the playbook against all 3, right? So it's actually going to reference a file, and it can have 1 IP in there or 5, it doesn't matter. And it's going to go through the play, which is the same playbook that we saw, which is installing all the packages. And then boom, at the end, it's going to kick out your EC2 IP. So you can see here with a basic EC2 setup of 1 instance and a configuration of tools, it only took 2 minutes, so you can see how much time that saves you just installing basic tools. You know, going through the console could take you, 10 minutes or whatever, 10, 15 minutes. And that's a lot of time saved. You add that up over a year. But, if you're building phishing infrastructure, for instance, or command and control infrastructure with redirectors or CloudFront, you can automate all of that. We've done that here at Optiv. We have an internal tool that we use. It's built in Go, but it'll build take less than 8 minutes to build an EC2 instance with, like, say, Cobalt Strike on it. You change your DNS to point to that Cobalt Strike, so you can pull a certificate, and then it'll build a CloudFront instance for it. Really, really cool stuff. You can do all sorts of stuff with this. You can hopefully you take this tool and you can build from it. You can do different things with it. It'll give you some ideas. You can obviously build an even better tool. There's something basic that just give you an idea of what you can do. But yeah, I hope you enjoyed it. Please let us know if you have any questions. Let me know on the Discord. And yeah, don't wait, automate. That's what I always say. So I appreciate your time, and thanks for joining.